Hey girl, you had a little question about this problem, and you can do it. You may, if you've already been watching the other videos, we're going to learn the power rule for integrands here, where you add 1 to the exponent, put it over it, and then use a fundamental theorem of calculus to evaluate this. But right now we're just looking at graphing the integrand, which is this part right here, and then thinking about the area under the curve from -5 to 7, calculating that area with some geometry formulas, and then figuring out the answer from there. So let's begin by thinking about that function. All right, so f of x, the integrand is f of x equals x plus 7. All right, so we'll go ahead and calculate the endpoints. So f at -5 is going to be -5 plus 7, which is 2. So we have the coordinate -5, 2 on the graph. And then f of 7 is just 7 plus 7, which is 14. So we have the point 7, 14 on the graph. So if we want to think about our graph here, let's see if I can get some more space. We're going to look at the line from the line x plus 7, but we're only going to consider it from -5, so at -5, 2 here, and then at 7, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so then at 7, 14. So it's this line. Okay, and we want the area under the curve. So if you think about it, this area is really represented, I know it's kind of a crappy drawing, but just imagine that, is the area of this trapezoid right here. See if I can make my drawing better by coloring it in. Not really. Okay, so a trapezoid, the way you find the area of the trapezoid is you add the parallel bases, and then you find the height. The height is actually the distance between the two parallel bases. So you can count it here. It's from -5 to 7, which is 12 units. If you do 7 minus -5, that's 12. And this height right here is just the y coordinate, which is 14. That was the 7 plus 7. And this height right here, or this base here, is going to be 2, because that was -5 plus 7. So the formula for the area of a trapezoid is area equals 1/2 the height times the sum of the parallel bases. So let me write that correctly. All right, so 1/2 times the height times the sum of the bases. All right, and so as you can see then, our height was the 12, because that's the distance between the parallel bases. So it's 1/2 times 12 times the sum of the bases, which is 2 plus 14. So this is half of 12, which is 6, times 2 plus 14, which is 16, and that's 96 square units would be the area there. So you come in here and you can say 96. Okay, so I hope that helps.